The final topic in this lesson is about avoiding L'Hopital's rule mistakes. Here are some typical mistakes. 1. Applying the derivatives right at the product. Taking the derivative of sine, taking the derivative of log, we get cosine times 1 over x. No, that's not right. L'Hopital's rule applies only for fraction. So you have to make it into a fraction like this, and then you can take the derivatives. Please remember, as usual, we kept log of x in the numerator and trigonometric functions down, and then applied L'Hopital's rule appropriately. Some trig identity, and then we get the answer. How about this problem? Well, if you use L'Hopital's rule, it works fine, but I've seen some students using something like this, a quotient rule. It's been a long time since I saw this, as a matter of fact, I admit, but I did see. The other type of mistake is a little bit more prevalent, using L'Hopital's rule, the derivative over derivative, when you have to use quotient rule. In any case, be careful. Quotient rule is for derivative computation. L'Hopital's rule is for limit computation. Next, skipping the plug-in step. What about it? Plug in x equals to 2 here, and do we actually get 0 over 0 or infinity over infinity type limit? In that case, you can use L'Hopital's rule, but if you skip that step and just apply L'Hopital's rule, you get this kind of bogus computation. Take the derivative of numerator, derivative of denominator, and then plug in numbers. It looks like you're going to get x equal to 3, limit equals to 3, but no, this is incorrect. If you plug in the numbers, you're not going to get 0 over 0. You get 4 over 0, so this is undefined limit. This is one of the trivial limit problem. So the chance is you're not going to see this kind of thing in the exam because it's more of a trick question. But in homeworks, yeah, you can see that. Now, here's another type of problem. If you see this as infinity over infinity types limit for rational functions, in that case, you recognize there's an alternative method. L'Hopital's rule is not the best way to do, even though it works in this particular case. Take the derivative of numerator, take the derivative of denominator, and then we get, well, another infinity over infinity. So do it again. We get 4 over 2 is equal, excuse me, there's a typo. The limit is 2. 4 over 2 is 2, not 1. Okay, alright. But then again, what if you have to do it, say, 20 times? If you have something like this, 20th power, what are you going to do? Are you seriously going to take the derivative 20 times, both numerator and denominator, applying L'Hopital's rule 20 times? It'll work, yes, but it's not really an efficient way to do. Much better, you simply take the highest order term and then throw away lower order terms, because lower order terms are much smaller compared with the highest order terms, and then simplify. That is a proper way to do. More practical way to do, as a matter of fact. Okay, another typo I just corrected. Okay, what if we have much bigger power, say 20th power? Will that make difference in this method? No, not really. We can disregard all these, and what we get? Direct cancellation, and we have the answer. So you do not have to take the L'Hopital's rule 20 times. Here's another problem, and this is the most prevalent mistake. If you have limit at infinity with radicals, L'Hopital's rule flat out fails. It doesn't work. Here it is. Let's try L'Hopital's rule. Take the derivative of this square root function. Oh my goodness, this is what you get. And then this square root function will give you something like this. Now what? It's impossible to handle this. It's too complicated. Taking the derivative once more with all these square root with quotient rule, that's crazy. It doesn't work. it flat out fails. So how do you do? We'll just take the highest order terms, of course. Highest order terms here, disregard the rest, highest order term, disregard the rest, and then continue. Simplify, simplify, simplify. In the end, you get the answer. One thing you may have to be extra careful is when x is going to negative infinity and we have odd power, you may have some sign change. But in any case, that's a whole lot of different issue. In any case, L'Hopital's rule flat out fails in this case, so please be careful. Another situation that L'Hopital's rule doesn't work, well, another radical example, infinity minus infinity type problem like this. How do you work it out? Multiply the conjugate and then FOIL it out, and what do you get? You get infinity over infinity type limit, but with radicals. So instead of using L'Hopital's rule, we do the same thing. Disregard the small order terms, that's 2x and that 3x, and what do we get? We get pretty much the same thing as before. We get this kind of simplification. So this is how you handle limit problems, limit at infinity problem with radicals.